So we're gonna do an example that's very similar to what you have to do in your papers. So in this case, we are using Pythagorean theorem to find the missing sides of a triangle. And from there, what we're gonna do later on is find sine of special angles such as 30, 60, 45. Okay, so here's the example I'm going to create. It's a little different from what you have in your papers. It's still very similar, so you should be able to use it later on as an example if you're struggling to figure out how to do the first problem. Okay, actually, I drew this in the wrong spot. I need more space, and you'll see why. So, we have a triangle, and let's name this triangle A, B, C. It's a right triangle over here. It has a hypotenuse of 10 centimeters. And we know that this angle is equal to 60 and this angle is equal to 30. The question we have is, what is the length of AB? What is the length of BC? And using BC, AB, BC, and AC, so using all these sides, we're going to find what is sine of 60 without using a calculator. Okay, so here we go. If I extend this side BC by exactly the same distance, and I call this point D over here, so these two line segments are equal, I get another triangle which is actually congruent to the original triangle. So what I just did is I took triangle ABC and I created a triangle ABD which is congruent to ABC. Why are they congruent? Because they have two sides of one triangle are exactly equal to two sides of the other triangle, and the angle in between is also the same. So if you remember from Helen's class, we have a side angle side postulate in geometry, which tells us that if we have a side, an angle, and a side of one triangle equal to a side, angle, side, and another triangle, these two triangles are congruent. If they're congruent, that means that their angles are equal, so this is also 60 and this here is 30. So this total angle over here is actually 60 as well. Therefore, what do I have? I have an equilateral triangle. An equilateral triangle. If we have an equilateral triangle, that means that all of its sides are equal to 10 centimeters. So if all of its sides are equal to 10 centimeters, over here I have half a side, therefore this side will be 5 centimeters. Now, I'm going to look only at triangle ABC. Triangle ABC is a right triangle. It has a right angle, right? Therefore, because it's a right triangle, I can use the Pythagorean theorem. Here's how I'm going to use it. I know that sine AB squared plus side BC squared, those are the two legs, is equal to the hypotenuse squared. I don't know AB, so I'm going to call it x right now. So x squared plus 5 squared equals 10 squared. X squared equals 25. Sorry, 10 squared, I made a mistake, plus 25 equals 100. How do I solve this equation? I want to eliminate 25. I subtract it on both sides. X squared is equal to 75. Now, I also tell you that I don't want you to use a calculator. I don't want you to simplify those answers to some weird decimals. I want you to keep them as square roots and radicals. So I need to take the square root of both sides, and what I get is square root of 75. However, I can write 75 as 25 times 3. And this is equal to square root of 25 times square root of 3. This is a property of roots. I can always split them when I have multiplication. Well, guess what? Square root of 25 is simply 5 times square root of 3. So great, I got this side over here, and this side is equal to 5 square root of 3. Now, I know I found both sides. I found that AB is square root of, it's 5 square root of 3, and I found that BC is just simply equal to 5. And I know that the hypotenuse is 10. I'm going to use that information to find sine of 60 degrees. Sine is equal to opposite side divided by the hypotenuse. So this is the opposite side over here, and here's the hypotenuse. So sine of 60 degrees is equal to 5 square root of 3 divided by 10. Guess what? I can simplify this fraction over here. If I divide the top by 5 and the bottom by 5, I get sine of 60 is equal to square root of 3 over 2. Okay, well, you have to do pretty much the same process. I hope this helps, and you should be able to figure out all the other problems on your own. If not, always feel free to ask questions.